Hi Akshit, welcome to SPRF Climate Hope, a podcast by Social Policy Research Foundation where we break down pressing policy at the intersection of climate, policy, and people. In this episode, we explore themes from the Center for Science and Environment State Environment Report 2024 with a focus on climate change adaptation in India and some key highlights of the report. We'll be diving deep into how climate change is shaping realities across India, from the farms to floodplains, and from the policy desks to disaster-hit communities. Akshit has worked as a senior journalist and climate expert with Down to Earth. Thank you for joining us, Akshit. Let us begin with a snapshot. According to SCR Report 2024, India witnessed 255 extreme weather events in just the first 274 days of 2024. These include flash floods, heat waves, droughts, massive landslides, and the most devastating one in Kerala, claiming over 200 lives. And these are just recorded ones.
So basically the data shows that 255 out of 274 days, there were any kind of extreme weather event happened in some part of India. Okay, and what it shows is the regularity of extreme weather events in India. There are different kinds of extreme weather events that affect India. There are heat waves, there are cold waves, there are flash floods, heavy rain, there's storms, lightning, and there's cyclones. So different kinds of events affect different parts of India, but the regularity of it is such that some part of India all throughout the year is going through some extreme weather event, which includes all of these extreme weather events. And the devastation that happens is not just loss of lives. There were some, in these 9 months, I think there were some 2,000, more than 2,500 people who lost their lives. There was also a lot of crop area that was affected. Some 3.2 million hectares of crop area was affected, in which there might be farmlands, say in Maharashtra, which was the most devastating. Then also croplands in Madhya Pradesh, in Tamil Nadu, in West Bengal, and places like Bihar, which were affected by floods. There's also a damage that happens to houses and damage that happens to animals that are killed. And most of these animals are, say, cattle, sheep, on which many of these people will also depend upon for their livelihoods. So it's not just lives being lost due to the extreme weather events, but it's also the livelihoods that are affected by these extreme weather events.
So what's interesting is we are not just seeing events. We are not seeing them as isolated events. We are seeing a pattern of regional disparities and a shifting change in climate behavior, a big change, right? So throw some light on how these regional disparities play out for us, and how extreme weather is manifesting across India, and has this variability evolved over the past few decades?
Okay, so basically different parts of India, because India is also geographically very diverse. For instance, there's the Himalayas to the north. Then there are Western Ghats and Eastern Ghats along the peninsular coast. Then there is, in the northeast, there are lush rainforests. And then there's a Thar desert, which is towards the west. And then in central India, it's mostly the plains. Right, the river plains. So different kinds of extreme weather events affect different parts of the country. For instance, in the plains in central India and northwest India, it's mostly heat waves, heavy rain, floods, which are riverine floods, as in the rivers get flooded and then they obviously cross the banks, and the crops or the agricultural fields get affected, or cities get affected. There are urban floods as well. So there are different kinds of, in Himalayas, mostly it's flash floods, landslides that happen due to very heavy rainfall falling in very short amount of time. For instance, cloudburst. In a cloudburst, within an hour, there's 100 millimeters of rainfall that happens over a very small area. For instance, around 20 to 30 square kilometers of area. And because of that, there'll be a flash flood downstream, and then there will be landslides. So that is the most common occurrence in the Himalayas. For the Western Ghats, there are again landslides. For instance, what was seen in Wayanad in Kerala last year, where more than 200 people were killed within a span of a night, actually. So that, and then in the central part of the country and in some northwestern parts, there are also lightning and storms. Storms include dust storms, they include hailstorms, and hailstorms have a massive impact on agriculture because they destroy crops. And this is the time period, basically pre-monsoon, from around February, March to May. This is the time period when hailstorms happen across, the central part of the country, which is Madhya Pradesh, Maharashtra, also northwestern parts like Rajasthan, Haryana, UP. All these areas get affected, and crops are obviously damaged, and also cattle and other animals are also killed by these extreme weather events. In the northeast, there's also different kinds of extreme weather events that happen. Lightning is very predominant. A lot of people get killed by lightning, and lightning is also a very silent killer, as in because they are very events that are happening all over the country, and then the data is coming in, and then it's being collated. So once you get the final data, that is when you realize that the number of deaths that happen due to lightning, which is higher than cyclones, heavy rain, flash floods, landslides, and which is very surprising because it is happening so disparately. So that is why you don't realize that it's actually killing so many people, even though like the numbers are, if you look at the numbers, they're pretty high. And lightning kills most people in eastern part of the country because that is more prone to lightning. For instance, northeastern states like Assam, Meghalaya, Arunachal Pradesh, and then the eastern part like Bihar, Jharkhand, Odisha, parts of Chhattisgarh. All these areas are very prone to lightning, and a lot of people get killed by that. So this is basically how diverse geography also affects what kind of extreme weather event is more predominant, or these areas are more prone to.
Can we look at like these are short span of events, right? They happen overnight, over days.
Yeah.
But what about the slow onset events like depleting groundwater, glacial melt, sea level rise, whose impacts aren't visible? They are invisible to us, to be very precise. Could you unpack those for us?
Yeah, so slow onset events are again happening in a very invisible manner. For instance, sea level rise along the Indian coast. Sea level rise globally was happening in the past few decades at around 2.3 mm per year. The sea was rising at 2.3 mm per year. Now it has increased to 4.77 mm around. So it has doubled. But in fact, in Bay of Bengal, if you look at the data, it's even higher than that. It's around 30% higher than that.
It's higher than the global average?
Global average. So Bay of Bengal is actually, the sea level is rising at a rate that is 30% more than global average. And most of this is affecting the eastern coastal states. For instance, Odisha, West Bengal, Andhra Pradesh, and Tamil Nadu. And many of these states are also prone to cyclones. So when sea level rise combines with cyclones, which also Odisha also gets affected by cyclones, West Bengal frequently gets affected by cyclones, so does Tamil Nadu, so does Andhra Pradesh. So when these two combine, the coastal flooding increases. So when a cyclone happens, when it is just moving onto land, there's something called storm surge that happens. Basically, it increases the level of the tide. The regular tide that happens, it increases it by say 1 meter to 4 meters. So if the tide increases, the entire water comes over to the land, and the coastal flooding happens. And this happens very regularly during a cyclone. So what now happens is, once the sea level is higher, the storm surge again is even higher than it used to be earlier. So now more areas would get flooded than previously. Also, cyclones are carrying more rainfall now than before. So that rainfall combined with the storm surge will increase the coastal flooding. And because of that, the entire eastern coast has become extremely vulnerable to both sea level rise and combined with cyclones. And then there's also invisible change that's happening in the forests. For like example, a good example would be the rainforests of Western Ghats, one of the most biodiversity rich areas in the world. Okay, and these changes are so invisible that only the people who are there, living there, and are dependent on the produce that is coming out of these forests. For instance, the wild fruits. So these communities basically collect the wild fruits and sell them in the market. And they have been saying, or I have reported on it, that the number of these wild fruits, the productivity of the wild fruits has decreased drastically in the past few years. And they don't understand why it's happening. And when I spoke to researchers, when I spoke to scientists, they could give me some reasons why it could be happening, and all of them basically indicated climate change, warming as one of the reasons that could be there. But these changes are very, very slow. They're happening at a rate that is very invisible to the naked eye, but they are happening. And these are the kind of events, and it can in fact be called a forest drought.
A forest drought,
which is a concept actually. Forests around the world, including the Amazon, are undergoing drought, where they're basically drying up. And because they're lush and green from the outside to the naked eye, you can't really realize that those changes are happening within the forest. For instance, even photosynthesis, which is the basis of all life on the planet, is getting affected by warming. Once the temperatures go up, photosynthesis decreases. So the basic productivity of these forests is also decreasing. But all of this has to be researched. Like, all of this has to come out of scientists. They have to do more research and let us know that what exactly is happening in these forests and how much of an impact is there. So these low onset changes, these droughts that are happening and sea level rise is invisible to the eye, but yeah, they're happening.
That brings me to an interesting question. Climate resilience amongst informal workers, especially through the coastal area in India, eastern coast and the western coast. Given that Bay of Bengal is rising with such amount, does the same is there a similar occurrence for the Western India? And if so, what's the state of informal workers? Do they look at this in the same idea?
Yeah, so informal workers, mainly fisher folk, who are there along the western coast and eastern coast. Eastern coast, they already realize it. Their fish stocks near the coast have gone down drastically because of sea level rise, because of warming, because of a lot of factors, because of pollution. There's so many things that are happening along the coast at once. So you can't really pinpoint exactly why it's happening, but you know the effects, you know the impacts. Because when you speak to those people, when you speak to fisherfolk along the eastern coast, at least that I have done, they say that their productivity, their fish catch, basically, wild fish catch has gone down by 30 to 40% approximately, according to their estimates. And they say that it's happening because of fish not coming to the shore. So they're moving elsewhere. That is what their thing is. And they have to go deeper into the sea to be able to catch the fish, which they can't do because their boats can't go in so deep. So that is where trawlers come in and all of those things that is happening. But the traditional fisher folk, the informal fisher folk who are not part of the formal economy, for them it is extremely tough to basically go into the sea now and catch fish near the shore. They have to go in deeper, which also risks their lives. Because with those boats, if they go in deeper, it becomes a life risk for them. Along the western coast, also this is happening, but it's a little slower. Along the western coast, what has changed is the number of cyclones. So earlier, Bay of Bengal was the one which was prone to cyclones, and has historically been so. Because Bay of Bengal is also warmer. It's a little warmer than the Arabian Sea in general, on average. And warm waters basically produce cyclones. Warm water is required. Warm water, moisture, and certain winds are required for a cyclone to originate and then become more intense. Along the western coast, it was not as much before, but now due to warming, the Arabian Sea is also producing a lot of cyclones. For instance, there was this cyclone in 2021, in May 2021, called Taute, which basically affected Gujarat, which affected Kutch in specific, which is a dry area, which is a completely arid area. But there were lakes that were formed in Kutch because of the kind of rainfall that happened due to the cyclone. And they're not used to it. The people are not adapted to such kind of a thing. So along with sea level rise, cyclones, western coast is also going to getting affected by climate change.
So one way to look at this is extreme weather doesn't change landscapes. It changes lives.
Yeah.
It's the marginalized, women, children, Adivasi communities, smallholder farmers who bear the human cost, who bear the burnt of it. They lose homes, incomes, and means to recover. And the more drastic these climate extremities happen, the more likelihood is they are going to be impacted at a greater scale. Can you tell me a bit more about the biggest socio-economic impacts of these events in general, and particularly towards the vulnerable communities in India? and how do these events deepen existing inequalities?
So, if you look at India, most of the vulnerable communities, the communities which are extremely vulnerable to climate change, also live in places which are rich in natural resources. Right. They, for instance, the northeastern part of the country, along the coast, in the Western Ghats, in the Himalayas. So all of these communities are also living in places which are extremely diverse, extremely resource rich, but also extremely vulnerable. That is why extremely vulnerable to climate. Because say along the coast, if you go to Kerala, for instance, extremely vulnerable to climate change, because the distance from the mountains, from the hills, from the Western Ghats to the coast is very small. It's very short. So whenever the rainfall happens on the western slopes of Western Ghats, if it's extreme rainfall, then immediately the water will flow and the communities will get affected. And a lot of these communities are extremely vulnerable and also extremely marginalized. In fact, if you go a little further up in the Western Ghats, in the Karnataka part of the Western Ghats, there's a lot of tribal communities which live in those parts, and they are the ones who are also, as I said, collecting the wild fruits and that. The heat waves that are happening along the coast, which was not the case earlier. Heat waves were a very significant part of central India and northwest India. But now even the Himalayas and the western coast and the eastern coast are also getting affected by heat waves, which was not the case earlier. And because of that, the drying of the forest is happening. The same case is true for the northeastern region of the country also. For instance, we can take the case of Assam. Assam is completely Brahmaputra River Valley. The people are completely dependent on the river and the silt that it brings for their agriculture. But now, instead of silt, there's sand that is coming in from the mountains, because the silt is all gone. The river has flooded so much that the topsoil, which basically bears the crops, that is not there. So sand is coming in. So instead of their agricultural fields getting inundated by silt, it's getting inundated by sand, which can't be cultivated.
And the cultivation is affected.
Yeah, basically the cultivation is affected. And because of that, they don't have any other option. They don't have any other alternative livelihood to go to if they don't practice agriculture. So that is something that is happening there. The same is happening with people in Odisha. The fisher folk of Odisha are extremely vulnerable, and most of them are from vulnerable communities, from marginalized groups. And they are getting affected by coastal erosion, because whatever land area is there where they're living right now, that is getting eroded by the sea. And that is happening because of cyclones. It is happening because of sea level rise and continuous dynamic movement of the sea. And there's something called extreme sea level events, which basically, whatever high tide is there,
a significant portion of the land is washed away.
Land is washed away. And there are whole villages which are washed away. So slowly, there are so many villages that have been abandoned. And there are villages which were rehabilitated, but were not rehabilitated well. So that is why those communities, because they did not want to go deeper into the land, because they would be far away from the sea and won't be able to fish, they are still living there. They're still taking the risk to live on the coast, even though they know that the next tidal event will take away their village and them. But because they're so much dependent on the sea that they don't want to go inside. And because the communities were not involved in the decision making while rehabilitation was being planned, that is why they don't agree with the government, or they don't agree with the administration, and they're not moving. They're taking all the risk. So all these people are extremely vulnerable to climate change, but they don't have the resource basically to maybe negotiate better, or basically come out of it, adapt to it. And the government, at least the current policies, are not helping them as well.
My follow-up question would be some examples of long-term disruptions to livelihood that we have witnessed so far.
That happens basically because of repeated events. For instance, if a drought has happened somewhere, for instance in Jharkhand, there's a drought that has been there, less rainfall that has happened for the past 3 years. And Jharkhand is predominantly rice. It cultivates rice, and rice needs a lot of water. So once 1 year there's a drought, there's no rice production, then maybe you can use the previous year's stocks. Then for the next year there's no stocks, right? So it becomes a repeated thing, and then you become extremely vulnerable and you go into debt. And that is what is happening to farmers in Jharkhand. And the same thing happens to, say, farmers in Bihar, where the problem is flood. Kosi River floods regularly every year, right? And it's now flooding even more because there's rainfall that is happening in Nepal, and that water is coming in as well. So where earlier the floods that were nominal or not as swift or not as much, like the extent was not much, now it's extensive. So earlier, some land that used to be available for cultivation is even that is not available. So such things. So once there's this kind of repeated events that keep happening, it makes livelihood extremely difficult. For instance, also in Assam, as I told you, has been living with the Brahmaputra River. The people have been living with the Brahmaputra River for centuries now. They are well adapted to the flooding of Brahmaputra because Brahmaputra floods naturally. But they know their traditional knowledge can take them only to a certain extent. For instance, a district like Golaghat gets flooded 3 times a year. They know when it gets flooded. The first wave of floods, the second wave of floods, the third wave of floods. After the third wave of floods happens, they usually sow their rice crop. They are predominantly a rice growing state, they sow their rice crop. But there are some years when a fourth wave of flood has also come, when a fifth wave of flood has also come. So that knowledge is not available for them because they don't understand or they don't know that climate change is happening, global warming is happening, right? So that makes their livelihood extremely difficult. Now, there's no alternative, as I said, to livelihood. So repeated events over a period of time make these communities, make people extremely vulnerable because of loss of livelihoods. And there's no alternative to whatever they were doing earlier.
This also brings me to the point, the CSE report this year sounds the alarm about India's monitoring system and how they may be missing the mark, especially along our coasts, given that the frequency of super cyclones might amplify to, let's say, 3 times. What about the cyclone tracking instruments? Are they inadequate? Are we progressing towards them becoming adequate? Or are we looking at them in a light where we no longer want to depend on them and we want to move to IPCC and see them in a global light?
No, so India's cyclone monitoring is not bad. Because the first super cyclone that we know of in our memory was in 1999, and it happened in Odisha. After that, Odisha got together and they put in a cyclone monitoring system, which was governed by IMD, obviously, the Indian Meteorological Department. But they also took a lot of steps locally within the state to be able to prepare for cyclones. Okay, but that also has its limitations. Why? Because the character of the cyclones itself is changing.
And it's changing as fast as we are not able to produce policies?
No, we are not able to produce policies. We are not able to put in instruments in time. So cyclone monitoring is a very complicated thing that happens. Okay, it is done centrally by the Indian Meteorological Department. They basically look at the cyclone when it forms as a low pressure area in the Bay of Bengal, somewhere usually happens near the Andaman Islands. The low pressure area forms, and then it starts moving towards the coast. And then it starts intensifying. It becomes a depression, then becomes a deep depression, then becomes a cyclone, and then the various categories of cyclones, intensity. The intensity of the cyclones, there's a gradation for that. So now, so the early monitoring of the cyclone is happening through satellites. Completely by satellite. The satellite is watching it and it is recording where it's moving and how much is the wind speed and all of that. Once it comes very close to the coast and it is intensified, there are Doppler weather radars which use radio waves to basically send signals into the cyclone, get back those signals, read them, and then get to know how much moisture is there, how much rainfall is there, how much the wind speed is there, all of that. Okay, and there are some, I think 7 or 8 Doppler weather radars that are there along the eastern coast of India. So that is one thing. Then there's also something called high speed wind recorders, which are there along the eastern coast. There are some 25 of them that are surface winds. So surface winds, satellite, Doppler radar. These three are giving the information to IMD, and IMD is able to tell where the cyclone is going to move and how much impact is going to happen. But IMD is not very good with, still not very good with how much rainfall is going to happen. That prediction is not, and where it's going to happen. It has been wrong with that. And in fact, in
Wayanad.
Not in Wayanad. Last year there was a cyclone called Dana. Dana. So that in that cyclone, basically it was seen that earlier it was moving towards West Bengal, and some models showed that it was moving towards Odisha, and they were confused about where it's going to move and how much rainfall is going to happen. So they were wrong about where the cyclone is going to land and how much rainfall it's going to carry. And that can happen with two kinds of, so observational data is very important for cyclones. And one is there's not enough high-speed wind recorders, high wind speed recorders basically on the surface. One is that data is required. And then there's also not enough observations on the ocean itself, because the cyclone initially is forming and moving over the oceans, over the Bay of Bengal. And their observations are required for the surface temperatures and the subsurface temperatures, which usually happen with the help of instruments called buoys. Okay, and there are not enough network of buoys to give you real-time information about not just surface temperature, because surface temperature you can still get from satellite, but subsurface temperature, which is very important for something called rapid intensification. There's a term called rapid intensification of cyclones, which has been happening for the past decade or so, and it is new. And it's not happening just in India, it's happening everywhere around the world. So during rapid intensification, what happens is a cyclone gains 56 kilometers per hour wind speed within a 24-hour time span. Okay, that means it is going from less intense to more intense really quickly. And that is by rapid intensification. And when this happens, the tracking of the cyclone becomes very difficult. And this has been happening very regularly. So to be able to track the cyclone well, including the rapid intensification, the subsurface temperatures are required. And for that, the observation system is required. So these are the things that are lacking right now.
So another point that I want to make here is the traditional knowledge systems. While coastal communities have been fishing for almost centuries now, they too have their own traditional knowledge systems, practices through which they can assess whether it's going to be really high tide, low tide, or assess whether it's going to be a cyclone anytime soon. What about them? How well can we integrate community-driven approaches into official disaster preparedness?
No, the understanding of cyclones within these communities, especially along the coast in Odisha, even in West Bengal, is very high. They understand cyclones very well. They know, in fact, they know it to a level where they can predict where the cyclone is going to move, because of their own understanding of how cyclones have moved before.
Yeah.
Because some of them, at least the people who are old enough, 60, 70 years, 80 years, they have seen many cyclones over there. They can remember those cyclones. In fact, people remember time in terms of that. But that is generally not used by the weather agencies. It's just adaptation for them locally. One good example that I know of, which I was talking about this with a scientist when I was doing a story on the climate change impacts in Northeast India. And there, the mountain springs in Arunachal Pradesh are drying up. Okay. And there was this whole talk about how to rejuvenate those springs, how to bring them back. And for that, you need the traditional knowledge of those people to identify where the aquifers are. Right. Because without that, because otherwise you'll have to run ground surveys throughout, LIDAR surveys, 3D surveys, that survey, geological surveys, all throughout the landscape to be able to identify aquifers. But those people who are living there, they already know where the aquifers are. So that traditional knowledge can be used to basically rejuvenate the springs. At that point of time, this was in 2021 when I was speaking about this. I don't know if it has happened or not, but yeah, this was something where traditional knowledge could have been used for climate change adaptation. One more thing where traditional knowledge comes into play is with varieties of rice, varieties of wheat, varieties of other crops which are resistant to drought or floods. Like certain places which are now getting flooded frequently can use these varieties to be able to grow crops even when it's flooded or when there's a drought, where crops which require crop varieties which require very less water, those can be grown instead of the regular varieties which need a lot of water. So this is also traditional knowledge, because these seeds and these crops have been there throughout. People have been growing them, but the conservation of these traditional varieties of rice, wheat, or any other crop, yeah, that is the main factor. But yeah, traditional knowledge does exist on that.
A lot of concerns around climate change adaptation has to do with food security.
Yes.
Right. And India being predominantly an agrarian economy, how do you see food security going to change in the next decade or so? Given that we are at 0.7% rise in our temperature over the last, what would I say, between 1905 and 2018, 0.7% of rise in temperature.
0.7 degrees Celsius.
Yeah.
So so that is also a concern, because I just wanted to add that point that the rise in temperature over this century for India has been lower than the rest of the northern hemisphere. There are certain reasons for that. It has to be investigated further, but it could be aerosol pollution, it could be irrigation, massive irrigation that has happened in India. Because of that, the temperatures have been the overall warming of the warming has been lower. But we have been seeing these extreme weather events that are happening even with this kind of warming. Now, if we reduce aerosol pollution, which we have to, because that's another health burden, that's a major health burden for a lot of cities in India, right? A lot of people are dying because of that. Once we reduce it, there is a possibility of warming increasing, and not just increasing, accelerating. Exactly. So now the crop area that is basically getting impacted is around 4 million hectares this year, 2024. Now we have the final figures. It's around 4 million hectares. Crop area has gotten affected by extreme weather events, and that includes floods, that includes landslides, that includes heat waves, that includes cold waves, that includes storms. Now that brings in a huge question mark on our food security, because India is predominantly, as you said, an agrarian economy. It's not just we produce food for our own consumption, right? We produce rice for our own consumption, we produce wheat for our own consumption, and extreme weather events are affecting all these crops, which are basically the basis for food security for India. For instance, in 2022, there were heat waves, extensive heat waves early from March to June, and they significantly impacted the wheat crop in northwest and central India. And crop yields went down by around 30% in some places. That's huge. India had to ban wheat export because of the decrease in quality of the wheat and also the production of the wheat. So such events will question the food security of the country. And once this repeated, as I said, events that keep on going on. For instance, heat wave doesn't occur alone. Heat wave, when it occurs, it also portends a drought, because after the heat wave, the water levels go down and all of that, the evaporation happens. That is why a drought happens. And then when drought happens, when the landscape and the vegetation is extremely dry, it also leads to wildfires. So there's a whole cycle of events that happens, and because of that, even more the impact on food security increases even further.
This also leads me to urban heat trapping. While the agriculture is being affected, and it's a visible change, and the invisibility of urban heat in metropolitans, to be very precise, how does the state look at the urban heat that's being trapped in metropolitan cities, especially in places like Delhi? And what are the challenges that we have in terms of adapting to such rapid heat patterns that we are seeing right now?
Yeah, urban heat, say in Delhi or even in Bombay, Mumbai or places like Bangalore or Chennai has been studied extensively. Urban heat is a well-studied concept. The only way to beat urban heat is to decrease the built area, as in break the built area with either green spaces or water bodies, because they will be able to break the heat pattern. Because if it's an extensive area that is completely built, it's completely cemented or it's completely concrete, that will absorb a lot of heat, and then it will also start radiating heat. And when that happens, that entire area will become like a heat island. That is what urban heat island effect is basically. If you don't break those heat islands with green spaces or with water bodies, till that happens, this urban heat island effect is going to increase further. Because the warming, it's not just the general warming that is increasing. It's not just gradual warming that is happening. It's also intense warming that is happening in very small spaces. That is what causes heat waves, by the way. So when that intense warming happens, these urban heat island effects amplifies that further. It becomes a feedback mechanism. And that is why there's a urgent need for cities to be built in a way where these urban heat island effects will be broken by either green spaces or by water bodies. Otherwise, there's no other way out, because this is going to increase in frequency and intensity further.
So ideally, the local governments and community organizations, they understand their geography best and are key to build resilience, right? So can we look at local governance and decentralization to be integrated better in getting and planning adaptation across the country? And how can our indigenous knowledge systems become part of the larger climate strategy?
I think it is the most important thing to be done, because people who are living there in those cities, in those towns, in those rural areas, in those mountains, hills, wherever they are, they understand their own geography the best. They understand their own vegetation the best. They understand their own climate the best. There's also a need for understanding something called microclimates. Because say within a forest, within a large forest, there'll be many places which will be very different, which will have very different climate. For instance, there's this place called Dandeli in the Western Ghats. This is in Karnataka. And within Dandeli is basically more of a grassland, less of a forest. And then with just a few kilometers away, there's Anshi forest, which is extremely lush, dense, evergreen forest. So within that small space of a few like 50-100 square kilometers, there is a huge diversity in the vegetation, and that influences the climate. So the climate of Dandeli is very different from the climate of Anshi, and that will be the case even within cities. Even within cities, there will be places which will be greener. For instance, within Delhi, the southern part of Delhi is greener than the western part or the northern part or the central part or the eastern part. Right, the southern part where we are currently, this is a greener part of Delhi, and that is why it will have temperatures which are a little cooler than the rest of the rest of the city. So this becomes a microclimate. So understanding this microclimate within cities, within regions, within the country, everywhere, is the most important thing to be done, and that can be done only at the local level with the help of the local bodies that are there, the local governance bodies, and also the indigenous knowledge that exists in these forests. For instance, I gave you the example of Dandeli and Anshi. The people of Dandeli are adapted to that kind of climate, right? They will understand that climate much better. The people of Anshi, very close by, but that they have been living with that climate for a while. So that is why they will understand. So those knowledge systems, which traditionally are already existing, have to come into play to be able to adapt to these changes that are happening rapidly.
One innovation and financing, and in light of this conversation on adaptation models, one of the biggest hurdles remains funding, right? Even with national and global climate finance mechanisms, the gap remains large. Recently, with the COP29, India rejecting the developed nations' offers because what they were offering was insignificant to what is required. In that light, what are the barriers? What are the actual barriers in financing?
See, the biggest barrier in financing, for instance, if we talk about adaptation, In mitigation, you will still find financing because it requires investment. It brings in profit. If you develop or if you establish, say, a solar power plant or a windmill or something, wind turbine, you get energy out of it. You get generate electricity out of it. You get profit out of it. So that part of it, private companies and developed countries are still they are pro financing that. They are into that. But for adaptation, because there is no profit mechanism in adaptation, if you plant a mangrove forest, which is going to help coastal population in, say, Odisha or West Bengal adapt to climate change, the private companies are not going to get any finance out of it. So that is a very fundamental problem, and public financing in the world is not enough to be able to cope with the changes that are happening.
So the urgency of climate financing is not urgent for the developed nations, for the developings.
Developed nations for themselves are doing it. But according to the Paris Agreement, the developed nations were supposed to provide technology, capacity building, and financing to developing countries every year for them to cope with whatever changes are happening, whatever impacts are happening, right? But they have never done it. The money that they have given, it has been in the form of loans, which has increased the debt burden of all these developing countries, instead of basically giving grants, which was basically agreed upon when the Paris Agreement was signed. So, and the same thing happened in COP29 in Baku last year, where the ask of the developing countries was around $600 billion annually from developed countries to developing countries, and mostly in the form of grants. But what was given was $300 billion, and that too not immediately, but till 2035 they have to fulfill. So they have not lived up to their thing. And nationally, India does have a certain amount of money to be able to put into adaptation, but I don't think it's enough. I think many of the other experts also would agree that not enough money is going into adaptation right now, and it has to.
Oh, another interesting pivot that I want to take this conversation towards is the buzzing tech world. The intersection of tech and climate in India has recently seen a surge, with companies investing in climate mitigation, as you said, climate mitigation technology, climate change mitigation technology, to be very precise. What about climate adaptation technologies? Are we looking at a sectoral shift in terms of climate adaptation versus climate mitigation? Are we seeing a gap that has been bridged within the nation in terms of how climate and tech are interoperable towards each other, or not?
So climate mitigation, as you know, renewable energy is being invested upon. There is significant investment in also other kinds of technologies like EVs, electric vehicles, which also will bring down fossil fuel emissions. But then climate adaptation technology, one of the main major adaptation technologies that are required is early warning systems for extreme weather events. But for instance, just in the case of cyclones, I said high-speed wind recorders are required. Observation systems on the ocean are required. Better satellites might be required. More satellites might be required. There's a lot of technology that is required for adaptation as well, because without that, early warning systems can't work. Communication systems, better, more efficient communication systems, because even though if early warning is even generated for an extreme weather event, if it's not communicated on time to the people who are going to be affected, it's useless, right? Yeah. So communication technologies have also to be developed in a way that these early warnings can be dissipated to people. But that is why, that is what brings me back to the same thing, that the profit mechanism in adaptation technology is not much. People are not going to earn a lot of money out of producing these technologies. But if the government gets involved, for instance, one adaptation tool that can be used where private industry can come in is parametric insurance. So because traditional insurance policies are based on verification, because only when the insurer basically goes to the place where this extreme weather event or something has happened and verifies that it has actually happened and how much loss has happened, only then the the insured, basically the person who has taken the insurance policy, gets paid their claim. But when you so to basically upend all of that, what companies have started doing in India also, there are good examples of that actually, where they define a threshold, a kind of parameter, and when that parameter is crossed, immediately the insurance gets paid to the person who is insured.
Immediately.
Yes. For instance, Nagaland as a state has an insurance policy, has a parametric insurance policy, which was put in place a few years ago, but this year they have again redone it with a different kind of with a different insurance company, and with, I think, a different reinsurance company also. So what they do is, if monsoon rainfall in Nagaland crosses 1500 mm, whatever sum is insured, say a crore or 2 crores or whatever, 10% of that is paid to Nagaland immediately to the state, and then they can take whatever actions they want to mitigate the impact of the flood or impact of the monsoon. Kahin pe agar, if there is flood somewhere, they will go and give money to the people who are getting affected. If it crosses 2220 mm monsoonal rainfall, the entire insured sum is paid to Nagaland state government. Right, and then they can take whatever steps, because 2220 mm is high. So there might be a lot of floods that would have happened, or a lot of landslides that would have happened. So they would need that money for mitigating that, for adapting to that. So that would happen. So this is a very good pilot, or this is a good experiment that is going on. And I think it could be done for more states. It could be done for more extreme weather events, and it could be done by the government, because this is a government initiative that has happened. It can be taken up by the central government, and then they can put in place for different kinds of states, different kinds of vulnerabilities exist, and they can be insured accordingly.
Great. So basically, we're saying that adaptation cannot happen in silos, and there's a huge potential in public-private collaboration, and also tech-driven resilience.
Yes.
This is tech-driven, right? Now, the last and the final question that I have for you is: what do you think are some of the key steps for India's adaptation roadmap down the line?
The first and foremost would be basically bringing in observational changes to data policy. Like, observational data should be paramount for adaptation. Without that, adaptation in India can't happen, because India is extremely diverse. It has mountains, it has coast, it has desert, it has forests, it has everything. And that is why the observational network in India has to be as dense as possible. And that includes all kinds of observational centers. It includes rain gauges, it includes temperature recorders, wind speed recorders, Doppler weather radars, all of it. Because only then will we be able to even begin to adapt to the extreme weather events that are happening, and also to slow onset events. For instance, monitoring of sea level has to also happen. Has to happen with the same instruments like buoys, right? So all of these investments have to be made. Observational data has to be brought in, and this is also going to help us forecast monsoons better. Monsoons are the most significant event for India, because most of the country's agriculture still depends on monsoons. Irrigation is very sparse. Only a few states have, like Punjab and Haryana, have a lot of irrigation. The rest of the states are dependent on monsoons for their agriculture. So for being able to predict or forecast monsoons really well, and where rainfall is going to happen, how much is going to happen, these observational data changes are required. But apart from that, investment in technologies is also there for early warning systems. Not just forecasts, but also early warning systems, so that people's lives and livelihoods can be saved in time. And for that, I think technologies are required, and India has to invest in them.
I think that's a good point to leave our listeners here with the caveat that technology is where we should invest in to figure out how to observe India's resilience in climate adaptation.
But also communities have to be placed at the center of policy, because without their knowledge, without their traditional knowledge, it won't work.
I think climate policy and people go hand in hand.
Yes, true.
Irrespective of where you are, who you are, what you want, climate policy and people are the centrality of climate hope for India. And thank you for having this conversation with us,
I'm glad.
Akshit. Looking forward to have more such conversations down the line.
Sure.
Thank you for being on this podcast with us. Nice to have this chat with you.
Yeah, thank you.